Hi guys, welcome back to Mathematics for Engineering 3. This is the third chapter, which is Laplace Transform. Today is the second section, which is the techniques to Laplace Transform. But before we, go to the techniques, lots of techniques today, how about we do some recap, okay? To talk about what we have learned in the previous video. In the previous video, we talked about the definition of Laplace transform, right? Which is it's an integral, right? It's the integral from 0 to infinity of e to the minus st ft dt. And that is the Laplace transform of ft. Okay, and the Laplace transform of ft is a function of s. Okay, don't forget about that. Okay, and here is the definition of Laplace transform. After that, we uh, compute the transforms for several functions, okay, using the definitions. They are actually not our focus, okay? They are not actually the main focus of this course, but you need to know the definition at least, to know what is going on, okay? And after that, we look at the table, okay, the formulas basically. So you have 7 basic formulas to Laplace transforms. Okay, so basically, if you do the Laplace transform for 1, you get 1 over s when s is bigger than 0. The Laplace transform of e to the kt is 1 over s minus k when s is bigger than k. Okay, and you have these 7 formulas, and you do have them in the exam, so you don't need to memorize them. Okay, you just need to be able to apply them to the given functions. Okay, and then we have the theorem. It says that if you want to find Laplace transform of f plus or minus g, you can find the Laplace transform of each of them separately, and then you plus them, or you get f minus g, the Laplace transform of f minus Laplace transform of g afterwards. Okay, on if you have the Laplace transform of kf, you can pull the k out when k is a constant. Okay, and that is just to say that the Laplace transform is a linear operator. Okay, you can split if they are the sum or the subtraction, and you can pull the constants out. Okay, and then we apply the formula to many functions, like for example that function, and and many others. And after that, I did some brush up on the properties of trigonometric functions. So basically, you need to know some trig functions so that you can apply them, so that you can apply the formula. Okay, because for example, for this one, if you want to find the Laplace transform for s cubed of 2t, in that case there is no such formula for psi cubed, right? We don't have that formula. We have Laplace transform for psi, so you somehow need to get rid of the exponent, right? The number 3, the exponent 3. And to do that, you need to use these basic formulas for trigonometric functions. But you have 12 formulas, but you don't have sine minus x is minus psi x, and cos minus x is cos x. Okay, so you better remember them. Okay, you remember, know that psi of minus a is the same as minus of psi a, and cos of minus a is the same as cos a. Okay, doesn't really matter if it's a or minus a, the cos is still the same, and you need to know that. Okay, in order to rearrange or to manipulate the trigonometric functions, so that you can apply the previous formulas to them. Okay, and today what we are going to be doing is to learn some techniques. In lots of cases, we do have some functions that we want to find the Laplace transforms for, but they don't fit the formula. Okay, they don't really fit the formula, which means that if you look through the formulas, you can't find any formula that you can use to that function. Okay, but there are some techniques that can help you, okay, so that you can go back and apply the formula. Okay, for example, this is the first technique. If you want to find the Laplace transform of L of e to the at ft, okay, you have ft here. You want to find the Laplace transform of e to the at ft. That is the same as the Laplace transform of f of s minus a. When f here, when the f here is the Laplace transform of ft. Okay. So to say it differently, if you want to find the Laplace transform of e to the at ft, you just need to find the Laplace transform of ft first. First, you find the Laplace transform of ft, which is fs. Okay. So you just ignore this e to the at. You find the Laplace transform of e to the ft first, and after that, you just do substitution. You change s to s minus a. So the Laplace transform of e to the at ft is actually f of, and then you change from s, you substitute s with s minus a. Okay, it will become clearer when you look at the example. Okay. For example, if you want to find this Laplace transform, okay guys, if you go back to look at the formulas, here we have the Laplace transform of exponential function, right? We have Laplace transform of exponential function. We have Laplace transform of t to the n. But we do not have a Laplace transform of e to the kt t to the n. We don't have the Laplace transform for the product. Make sense? In that case, we have no formulas to this problem, right? Because if you want to find the Laplace transform for e to the 5t, no problem, right? If you want to find Laplace transform for t to the 3, that is no problem as well. But we can't find the Laplace transform for e to the 5t t to the 3. There's no such formula. Okay, so in that case, we need to apply the theorem. Okay, the first technique that we just know. Okay, and I told you here, first, if you compare, it looks like e to the a t ft. Okay, the Laplace transform of e to the at ft, which means that right now e to the at is actually e to the 5t, and ft is actually t to the 3. Okay, 3 cubed, t cubed. Okay, so in that case, first we need to find the big fs, which is the Laplace transform of ft, which is Laplace transform of t to the 3. Okay, which is the Laplace transform of t to the 3. And to find the Laplace transform of that, just go back to the formula. The Laplace transform of t to the n is in fact divided by s to the n plus 1. So here the Laplace transform would be 3 fact divided by s to the 3 plus 1, which is 3 fact divided by s to the 4, which is 6 divided by s to the 4, when s is bigger than 0. Right? Right? Make sense? Make sense? Okay. Guys, in the exam, here, this is actually really important, I told you. But in the exam, it's not the focus. Okay, it's not the main focus. So even if you get this wrong, it's still alright. It's still alright. Okay, but you better get it right. Okay, but I'm just telling you because I just want you to know that even if you get it wrong, you are still fine. Okay, okay. But what you need to get it right is this guy. Okay, that is where your marks lie. Okay, so guys, next we need to find f of s minus, what is it, minus a, right, and that would be f of s minus 5, because e to the a is e to the 5, right? E to the at is e to the 5t, so a is actually 5. Makes sense? So it is, what is it, f of s is 6 divided by s to the 4, right? So here it would be 6 divided by s minus 5 to the 4. Okay, okay. When s is bigger than k plus a, so before that s is bigger than k. Right now our k is 0, right? S is bigger than k. This is our k right now. Let me use some other color. Right now this is our k, and then we have k plus a, so s is bigger than 0 plus 5, which is 5, and that is the answer. It's the Laplace transform of e to the 5t t cubed. Okay, okay, guys, again, let me sum it up for this question. I'm trying to go a little slowly for the first questions, but later on I'll go a little faster. Okay, so here you want to find the Laplace transform for e to the 5t t to the 3, okay, t cubed. And as I told you, if you go back to look at the formulas, okay guys, the way to study this course, okay, especially this chapter, is that you download the formula and then you print them and you put them on the table, and then you look at the formulas when you are studying, okay, so that you will be familiar with the formulas. Okay, so print them, guys, print the formulas and then put them on the table, and then while you are studying, try to look at the formula as well. Okay, it would help you to be really familiar with the formulas that you can have in the exam. Okay, so here, if you want to find the Laplace transform of e to the 5t t cubed, you don't have the formula for e to the 5t t cubed, right? We only have the formula for e to the at or t to the n, right? But we don't have the formula for the product. Make sense? And to do that, we need to apply this theorem, which says that if you want to find the Laplace transform of e to the at ft, okay, e to the at ft, you just need to find the Laplace transform for ft first, and then you shift. Okay, the Laplace transform of ft is fs, big Fs, and then you just shift from s to s minus a. Okay, so here, if you look here, these guys seem to be ft, right? It's e to the at ft. So this guy is actually ft. So to find the Laplace transform of e to the 5t t cubed, you just need to find the Laplace transform of t to the t cubed first, right? The ft. And to find the Laplace transform of ft, you get fs, which is the Laplace transform of t cubed, and you get 6 divided by s to the 4. And after that, you need to find the big F of s minus a. Okay, f of s is 6 divided by s to the 4. So f of s minus a, which is f of s minus 5. Don't forget, right now our a is 5, right? F of s minus 5 is 6 divided by s minus 5 to the 4. Okay, makes sense? You just do substitution. And here, it's just a condition. It's not the main focus, okay? I told you again. I'm telling you again. Even if you get this wrong, you still get the marks, okay? It's not the main focus. So don't be obsessed about that. But it's always a good thing to get it right. Okay? Cool. So guys, let's look at the next example. It's e to the minus t sine squared t. Okay? It's e to the minus t sine squared t. Okay, if you go and look at the formula, you will see that we don't have the formula for e to the minus t sine squared. Okay, but we also don't have the formula for sine squared, but we can use the properties of trigonometric functions, right? So we can, somehow deal with that. So here we're gonna use this technique, which is at e to the at without the minus, sorry, e to the at ft. And in that case, first, right now we let ft be sine squared t. Okay, we let ft be sine squared t. So first, we need to find f of s, which is the Laplace transform of sine squared t. Okay, but before we apply the Laplace transform, we don't have the formula for sine squared. Okay, we don't have the formula for sine squared. We need to somehow change sine squared to some other functions that we do have formulas for. Okay, so but guys, here I think it's quite easy, because sine squared is basically we need to get rid of the exponent, right? It's what we did before. We need to get rid of the exponent. So in that case, we need to get rid of the square. And how to get rid of the square? We know that sine squared is 1 minus cos 2t divided by 2. Okay, if you don't know that, you go back to the formula. Okay, it's actually this one. Okay, sine squared a is 1 minus cos 2a divided by 2. So sine squared t is 1 minus cos 2t divided by 2. Make sense? Okay, so if we plug this in there, we would have that it's actually Laplace transform of 1 half minus cos 2t divided by 2. Okay, which is Laplace transform of 1 half, or how about I just pull 1 half out, I get Laplace transform of 1 minus 1 half Laplace transform of cos 2t. Okay, is that good? And then guys, what is the Laplace transform of 1? We go back to the formula. Oops, sorry. Go back to the formula. The Laplace transform of 1 is 1 over s. See? Laplace transform of 1 is 1 over s. And Laplace transform of cos kt is s divided by s squared plus k squared. Okay, and the conditions are the same, which is s is bigger than 0. So in this case, we would have that Laplace transform of 1 is 1 over s, and Laplace transform of cos 2t, it means that k is actually 2, right? K is actually 2. So what we have here would be s divided by s squared plus 2 squared, which is 4. So fs would be 1 half of 1 over s minus 1 half of s divided by s squared plus 4 when s is bigger than 0. Okay, and that is fs. Make sense? let me do it a little further. I pull one, should I? I'm not sure if I should do it. Okay, I just leave it like that, okay? Just leave it like that, I just don't care. Okay, so the Laplace transform of e to the minus t sine square t would be f of s minus a, which is f of s minus 1, right? Because it's e to the at, e to the at, e to the minus t. It means that a is actually minus 1. Make sense? A is actually minus 1. Okay, so it would be f of s plus 1, which is 1/2, and then 1 over s plus 1 minus 1/2 s plus 1 divided by s plus 1 square plus 4 when s is bigger than here. From the theorem is k here plus a, right? K plus a, but k is the condition of the f, the big F, right? And a is the a, right? So the condition for the big F is 0 and a is minus 1. So s is 0 plus minus 1, which is minus 1. Okay, so the condition would be s is bigger than minus 1. But again, guys, this is not the focus. Okay, you just need to get this right. Okay, and that's it, guys. Okay, next, there's a note that the function f s minus a, which is the function f of s substituted with s minus a, right? When you substitute s with s minus a, can be written as fs s right arrow s minus a. Okay, it can be written as this. So this and this are the same thing. Okay, but sometimes we use that because it's a little easier to to write it that way. Okay, so the Laplace transform of e to the at ft is going to be f of s minus a, right? From the theorem, and then we can write it as fs s to s minus a. Okay, and fs is actually the Laplace transform of ft. Okay, and that will be a lot easier. Okay, so let's try to find the Laplace transform of e to the 4t sine 3t 3t 6 e to the minus 2t cos 5t, and that one is actually, first you can write it as Laplace transform of e to the 4t sine 3t, and then it's minus 6 Laplace transform of e to the 2t cos 5t. Okay, and in that case you just need to find the Laplace transform of sine 3t, right? 3t, right? You just ignore the e to the 4t. Okay, just ignore e to the 4t, and you just need to find the Laplace transform of sine 3t. So you will get the big F, and then you substitute s with s minus a, which is s minus 4 in this case. Okay, so if you look at the Laplace transform of sine 3t, you can write it this way. It's going to be Laplace transform of sine 3t, and then you substitute s with s minus 4, and then here it's minus 6 Laplace transform of cos 5t, and then you substitute s with s minus 2, which is s plus 2. Okay, you need to substitute s with s minus a, but here a is here a is 4, and the other one a would be minus 2. Okay, so s minus 4 and s plus 2. Here in this case is easier in terms of writing, right? You just need to forget the e to the 4t and e to the minus 2t. You just need to find the Laplace transform of sine 3t and cos 5t, right? And Laplace transform of sine 3t is, what is it? If you don't remember, go back to the formula. Okay, if you don't remember, go back to the formula. And the formula is 3 divided by s squared minus 9. Okay, 3 divided by s squared minus 9. And here, you just change s to s minus 4. And the other one, the Laplace transform of cos 5t. What is it? What is the Laplace transform of cos 5t? Laplace transform of cos 5t is s divided by s squared plus 5 squared, which is 25. Okay, guys, if you don't remember, go back to the formulas, okay? And then you just need to change s to s plus 2. Okay, and the condition for Laplace transform of cos is s is bigger than 0. The condition for Laplace transform of sine is s is bigger than k. So the condition here would be s is bigger than 3. Okay, which is the Laplace transform of sine. So it's the intersection of both conditions. Okay, and after that, we just need to write them down. It would be the it would be 3, right? It would be 3 divided by s minus 4 squared minus 9 minus 6 s plus 2 s plus 2 squared plus 25. Okay, and then you need to shift. It will be s plus k plus a, right? S plus k. S is bigger than k plus a. Okay, but k is 3. K is the condition before we do the substitution, right? And you have a is 4 and minus 2, right? So the intersection would be s is bigger than 7. Okay, but guys, again, it's not the main focus. Okay, so you don't need to get it right, or you don't even need to write them down. Okay, you just need to get the transform right. Okay, just need to get the transform right. Cool. Okay, and that is the answer. It's easy, isn't it? Okay, first you just you just need to look at the technique is e to the at ft. So you take the Laplace transform sine 3t, and then you do substitution s to s minus 4, right, which is from e to the 4t. And then you do Laplace transform of cos 5t, and then you change s to s plus 2, which is s minus 2, s minus a. And then you just do the Laplace transform. That good? Okay, next question. Find the Laplace transform of t cubed e to the 3t plus 4t e to the minus 3t squared. Okay, so before we do the Laplace transform, we first need to deal with this guy. Okay, and if we do the perfect squared, we get a plus b squared is a squared plus 2ab plus b squared, right? That's the formula. So here we have a squared plus 2 a b plus b squared. Okay, we get a squared plus 2ab plus b squared. In that case, we have that is t to the 4 e to the 6 3, right? It's it's t to the 6 e to t to the 6 e to the 6t. My bad, sorry. T to the 6 e to the 6t. You basically you distribute the squared into the parentheses. Okay, and here you would get 2 and 4, you get 8, right? 8 t to the 4 e to the 0. Okay, you get 8 t to the 4 e to the 0, and then you plus 4 squared is 16 t squared e to the minus 6t. Okay, so the Laplace transform of this guy is basically the Laplace transform of e to the 6t t to the 6 plus 8 Laplace transform of t to the 4 plus 16 e to the minus 6t t squared. Okay, and that will be what you need to find the Laplace transform for. Okay, and guys, Laplace transform of the first one is actually Laplace transform of t to the 6, and then you change s to s minus 6, right? It's e to the 6t t to the 6, so you look at that as an ft, right? T to the 6 as an ft. So you need to find the Laplace transform of ft, and then you change s to s minus a, which is s minus 6 in this case. Yeah, because 6 here is s minus 6. And after that, we get the 8 Laplace transform of t to the 4. And then we plus 16 Laplace transform of t squared, and then we change s to s plus 6. Okay, s plus 6, and that should be quite simple. Okay, guys, I told you the conditions are not the main focus. Okay, determining the condition is not the main focus. So from now on, I'm not going to write the conditions anymore. Okay, but if you want to know the conditions for any of the problems, you can come and ask me. Okay, but I'm not going to be writing the conditions anymore. I'm just gonna write down the transform. Okay, so I'm not going to write s is bigger than 0, s is bigger than k, or any of those anymore. I'm gonna stop writing that, and in the exam you need to write them down as well. Okay, so here you would have that the Laplace transform of t to the 6. What is it? It n fact divided by s to the n plus 1, right, which is s to the 7, and then you change here s to s minus 6, and then you get plus 8. Laplace transform of t to the 4 is 4 fact divided by s to the 5, and you don't need to change anything, right, because here it's just the Laplace transform of t to the 4. There is no e to the at. Okay, and the next one would be plus 16, and Laplace transform of t squared, you would have 2 fact, t squared, you would have 2 fact divided by s to the 3, and then you change s to s plus 6, and in that case the answer would be 6 fact divided by s minus 6 to the 7 plus 8 4 fact divided by s to the 5 plus 16 2 divided by s plus 6 to the 3, and that's it. That is the solution. Okay, as simple as that. Okay, first, you don't have the formula for a plus b squared, right? You don't have the formula for a plus b squared, right? You don't have the Laplace transform formula for a plus b squared. So to do that, you use the perfect square, right? Here, this guy is a squared plus 2ab plus b squared. So in that case, you just need to apply the perfect squared formula to this guy, right? To that guy. And in that case, when you apply that, you get the line in purple, right? And then you apply the Laplace transform to each term because they are the sum of three terms, right? You apply the Laplace transform to each of them, and you get e to the 6t, t to the 6, plus 8 Laplace transform of t to the 4 plus 16 Laplace transform of e to the minus 6t t squared. And if you, oops, sorry, I forgot the Laplace transform. Okay, I forgot the L. Okay, so just need to apply the Laplace transform for this term, for the L of e to the 6t, t to the 6. That one you need to use the theorem, right? Use the technique, which is to take the Laplace transform of t to the 6, and then you shift from s to s minus 6, which is s minus a, right? The second term is pretty simple. It's straightforward. It's from the formula, right? And lastly, the last term is you need to apply the Laplace transform to t squared, right? And then you shift s to s minus a, which is s minus minus 6. Don't forget, guys. Here it is minus 6. Okay, s is minus 6, so it's gonna be s minus minus 6. So you get this Laplace transform. Okay. Okay, the next technique, it is when you have t to the n, ft. Okay, here's when you have t to the n times ft. So in that case, if you want to find the Laplace transform for t to the n ft, it's the same as to, first you get minus 1 to the n, and then you differentiate f, the big F, which is the Laplace transform ft, n times. Okay, I'm not gonna prove it, okay? And this formula, all the techniques that I've been talking about are provided in the exam. Okay, so because you are engineers, in the live class, maybe I'll talk about the derivation of the theorems a little bit, but not here. Okay, so here we're gonna focus on the approach. So the Laplace transform of t to the n ft, that will be minus 1 to the n derivative, the n derivative of the big F. Okay, so first let's look at this example. Okay, so here clearly, if you want to apply this theorem, okay, this technique, we would take fx, ft as e to the minus 4t. Okay, we would take ft as e to the minus 4t, and then we first need to find Laplace transform of ft. Okay, which is, what is it? What is the Laplace transform of ft? It's the Laplace transform of e to the minus 4t. Okay, and if you go back to the formula, okay, let me go back to the formula. Here is Laplace transform of e to the kt is 1 over s minus k. Okay, it's 1 over s minus k. So here we have that is 1 over s minus, and k is minus 4. So it's 1 over s plus 4. Good? Okay. And after that, if you want to find the Laplace transform of t e to the minus 4t, is going to be, if you look at the technique, is going to be here is t to the power of 1, right? It's t to the power of 1. So it's going to be minus 1 to the 1, right? Minus 1 to the 1. And you take the first derivative, okay, of fs. Okay, guys, there's a typo here. Sorry. You need to change here from dx to ds, because f is a function of s. So if you want to differentiate the big F, you need to differentiate with respect to s. Okay, sorry, my bad. So here is going to be by ds, and that is going to be minus 1 d by ds of 1 over s plus 4. Okay, and that would be minus 1 d by ds of s plus 4 to the power of minus 1, and that is minus 1 times minus 1 s plus 4 divided to the power of minus 2, right? And the chain rule, you differentiate using the chain rule is also 1, so there's nothing to change there. So it's 1 over s plus 4 squared. That's it. Okay, so here we apply the formula, we apply the technique, the second technique, which is t to the n ft. Okay, so first we find the Laplace transform of ft, and then we differentiate that Laplace transform n times, and then we multiply it by minus 1 to the n. So here we look at this as ft, right? We take e to the minus 4t as ft, and then we find the Laplace transform of ft, which is e to the minus 4t, is 1 over s plus 4. Okay, and then you apply the technique, right? You get minus 1 to the 1, right? To the n. Right now our n is 1, right? It's t is actually 2 to the 1, right? So right now our n is actually 1. Okay, so what we have there is minus 1 to the 1, and you find the first derivative, right? The first derivative, and that is the first derivative. Okay, and that is the answer. You may ask me, can I use the previous technique? Okay, because if you remember, the previous technique is for e to the at ft, right? And the answer for this question is yes, you can. Okay, you can. So if you use the first technique, okay, if you use the first technique, you would need to take the Laplace transform of ft, and then you change s to s minus a, right? Right, you change s to s minus a, and in this case it's going to be Laplace transform of t, and then you change s to s minus 4. Okay, which is Laplace transform of t, s to s plus 4. Does it make sense? Right? Here we look at it differently. We look at it like this. It's the Laplace transform of e to the minus 4t t. And in that case, we take these as ft. Okay, and we apply the first technique, not the second technique. Okay, and once we do that, the answer would be, what is the Laplace transform of t? It's t to the 1, right? So you get 1 fact divided by s squared, and then you change s to s plus 4. So that's why you get 1 divided by s plus 4 squared. And as you see, they are identical. They are exactly the same, right? As we expected. Okay, so here we computed the Laplace transform differently. The first one is with the second technique. The second one is with the first technique. Okay, Okay, but anyway, when you get t to the n, e to the at, in that case, you can apply either technique. It's okay. Okay, if I were you, I would use this technique. I think it's a little easier because you don't need to, differentiate the function, right? Because here it's t to the 1. It's pretty easy. You just need to find the first derivative. But if it's t to the 5, you need to find the fifth derivative, and that is not fun. Okay, especially when when you need to differentiate the fraction, okay, the fraction or the quotient. Okay, it's gonna be really messy. Okay, but for some other questions, maybe you can't actually choose. For example, this question: find the Laplace transform for t to the 2 t squared sine 3t. This case you can't choose, right? You can't choose. There's no other choices, right? So you need to pick this as an ft, right? So here would be ft, and you get t squared, right? So first we find the fs, which is the Laplace transform of sine 3t. And what is it? What is the Laplace transform of sine 3t? It would be 3 divided by s squared plus 9, right? Right, remember the Laplace transform of sine kt is k divided by s squared plus k squared, right? Right, if you don't remember, look at the formula. You don't actually need to remember. You don't need to. Okay, there's a formula. So then the Laplace transform of t squared sine 3t would be minus 1 squared. Guys, here right now our n is 2, so it's gonna be minus 1 to the n, right? Look at the technique, guys. It's minus 1 to the n. See? And then you need to find the nth derivative, which is in this case, it's the second derivative of of the Laplace transform of fs, which is 3 divided by s squared plus 9. Okay? So if you want to find the derivative, 3 is just a constant. I'll pull it out. So this one is just 1, right? Minus 1 squared is 1. So I pull 3 out. So I get d by the s squared plus 9 to the power of minus 1. So in that case, we get minus 1 s squared plus 9 to the power of minus 2, right? That is the first. Okay, let's do it slowly. Okay, let's do it slowly so that we don't get it wrong. Okay, d by ds of s squared plus 9 to the power of minus 1 would be, what would it be? It would be minus 1 s squared plus 9 to the power of minus 2, right? You look at this guy as u, right? Derivative of u to the power of minus 1 is minus 1 u to the power of minus 2, and then you need to get du by dx, right? Right, the chain rule. Du by dx would be 2s. Okay, and in that case you would get minus 2s divided by s squared. Okay, let's put it like this for now. S squared plus 9 minus 2, like that for now. Okay, and after that you need to take the second derivative. Okay, which means that you need to differentiate this function again. You need to differentiate that function again. Okay, so to differentiate that function again, I'll take this as u. Okay, I'll take that as u, and take this as v. Okay, so we would use the formula. D of uv by ds would be du by ds u dv plus v du. Okay, duv is u dv plus v du. Okay, it's a product formula. So here we would have minus 2 u, which is s, dv, you would get minus 2 s squared plus 9 to the power of minus 3, and the chain rule you get 2s. Okay, u dv, and then you plus v, which is s squared plus 9 to the power of minus 2, and du is derivative of s, which is 1. Okay, so here we have minus 2. There will be minus 4s squared divided. Okay, let's put it like that for now. Plus s squared plus 9 to the power of minus 2. Okay, and that would be minus 2 minus 4s squared divided by s squared plus 9 to the 3 plus 1 over s squared plus 9 squared. So in that case, I multiply here by s squared plus 9, s squared plus 9, just to make the denominator to be s squared plus 9 cubed. Okay, to have the same denominator. And then we would have that it is minus 2 minus 4s squared plus s squared plus 9 divided by s squared plus 9 to the power of 3, and that would be minus 2 what is it? It's minus 3 s squared plus 9 divided by s squared plus 9 to the power of 3. Okay, and this would be I pull minus 3 out. Okay, I pull minus 3 out from here, so I would have minus 3 times 2 is 6, and s squared minus 3 divided by s squared plus 9 cubed. Okay, so right now I know that the second derivative is actually this guy. Okay, so I'll copy this to the next page. Okay, so right now we know that this is 3 times the second derivative will be 6 s squared minus 3 divided by s squared plus 9 cubed, which is 18 s squared minus 3 divided by s squared plus 9 cubed, and that is the answer. Okay, that is probably too small, right? Make it a little larger, but here is actually nothing. It's from the previous page. Okay, good. Okay, see, when you don't have choices, you need to use the second technique, which is t to the n ft. You need to differentiate. If t is squared, you need to differentiate twice. If it's t to the 5, you need to differentiate 5 times, and that's not going to be fun. But you know, if you don't have choices, so what else can you do? You still need to differentiate, right? Okay, so let me do some recap here. First, we look here. We take this and ft, so we get t to the n ft. So we have that n is actually 2. Okay, n is actually 2. So once we get n is 2, it's t squared sine 3t, right? N is 2. In that case, we would use the second technique. So we need to first find the Laplace transform for ft, which is the Laplace transform for sine 3t. And that is 3 divided by s squared plus 9. It's this guy. Okay, that is easy from the formula, right? We have the formula of sine kt, right? It's k divided by s squared plus k squared. And after that, we apply the second technique, okay, which is minus 1 to the n. Right now n is 2, so minus 1 squared is actually 1. We don't care, right? And we need to differentiate the big F twice by s, right? That and the writing in green, that is to differentiate s divided by s squared plus 9 twice, and we get in the end we get this thing highlighted by pink, okay. And after that, we just substitute this back in there. Okay, we substitute this in there because here is the second derivative, isn't it? Okay, so the Laplace transform of t squared sine 3t would be 3 times this, which is 18 s squared minus 3 divided by s squared plus 9 cubed. And that's it. Okay, let's look at this example. For this example, it seems like we can't use the first and the second techniques, right? Right, because it's it's t ft, it's not tft, and it's not it's not e to the atft, and it's not t to the nft, right? So it seems like we can't really use the both techniques, but actually we can use both of them. Actually, we need to use both of them, right? So for this one, we can look at it like this. We look at it as the Laplace transform of e to the 2t, and then we have 2 cos t, okay. And then we look at this function as ft, okay. So basically we need to, let's call it f1t. So basically we need to find the Laplace transform of f1t and then shift it s to s minus 2, okay. But to find the Laplace transform of f1t, it's the Laplace transform of t cos t. So we do need to let this be f2 t, okay. So for this one, we apply the first technique, okay. But if we want to find the Laplace transform of t cos t, we don't really have the formula for it, right? So we do need to go back to the second technique to find the Laplace transform of f1t, okay. So in that case, here is t to the 1. It's t to the 1. So it would be minus n to the power of 1 d by ds of Laplace transform of cos t. Okay, it would be d by ds of Laplace transform of cos t. And that would be minus 1 d by ds of, if you remember, the Laplace transform of cos t is s divided by s squared plus 1. Okay, it's actually cos 1t. Cos 1t, k is 1. So when k is 1, Laplace transform of cos kt is s divided by s squared plus k squared, which is s divided by s squared plus 1 squared. Okay, and then we need to differentiate this function, and I'll use the formula d by ds of u divided by v. That would be high d low, low d high, minus high d low divided by low. Okay, low d high minus high d low divided by low. Okay, that's the formula for the derivative of a quotient. Okay, so here we would have minus 1. Low d high is 1, is du by ds, right? So we look at this as v. Okay, it will be v, and this guy is u. Okay, so it's v du, and du by ds is actually ds by ds, which is 1. Minus pi, which is s, du is 2s divided by low, which is that one. So it's going to be minus 1 s squared plus 1 minus 2s squared divided by s squared plus 1 squared, and that would be minus 1 minus s squared divided by s squared plus 1 squared, and that is s squared minus 1 divided by s squared plus 1 squared. Okay, that will be s squared minus 1 divided by s squared plus 1 squared. Okay, and next, this is the Laplace transform of F1t. So this guy, what we want to find, which is the Laplace transform of F1t, and then we need to shift it, right? So the Laplace transform of t e to the 2t cos t would be s squared minus 1 divided by s squared plus 1 squared, and then we shifted s to s minus 2. So the answer would be s minus 2 squared minus 1 divided by s minus 2 squared plus 1 squared, and that is the answer. Okay, I hope it's not too hard. Okay, makes sense. So we just, first we split it like that, and we look at this guy as f1t. Okay, so if you want to find the Laplace transform of this function, you apply the first technique. So if you apply the first technique, you would have that you need to find the Laplace transform of f1t, which is the guy in green, and then you shift s to s minus 2, right? S minus a, that's the first technique. So you first need to find the Laplace transform of f1t. Okay, and to do that, it's the Laplace transform of t cos t, and you need to use the second technique. Okay, so you get minus 1 to the power of 1 and the first derivative of cos t. Okay, and that is what you have. Okay, after that, once you get the Laplace transform of f1, you just substitute s with s minus 2, and that's it. As simple as it is. Okay, cool. Before we go to another technique, I would need to introduce you a new term, which is the unit step function. Unit step function. Okay, so let a be positive. Okay, a is positive, and ut minus a is defined by ut minus a is 0 when t is less than a, and it's 1 when t is bigger than or equal to a. Okay, so draw a graph of ut minus 1. Okay, so guys, ut minus 1, it would be 0 if t is less than 1. Right now, don't forget, guys, our a is 1. Okay, our a now is 1, and it will be 1 when t is bigger than or equal to 1. Okay, it's greater than or equal to 1. So the graph of ut minus 1 would be here. You have 1 here, and this is t, this is u. So it would be when t is 1, 2, 3, the graph would look pretty much like this. It will be 0 until this point, and it goes to 1. Does it make sense? Does it make sense? Because ut minus 1 is 1 when t is bigger or equal to 1. Okay, and it's 0 when t is less than 1. Okay, sorry, there's a typo here. I shouldn't draw a graph when t is less than 0 because it's undefined. Because it's undefined when t is less than 0. Okay, so the graph starts when t is 0. Okay, let's look at the other one. ut is actually ut minus 0. Okay, so it's 1 when t is bigger or equal to 0. So it would look like this. Ut. Okay, and ut minus 2 is actually ut plus 2 is actually ut minus 2. Okay, t plus 2 is actually t minus 2. So this will be a. Okay, this is a. A is actually minus 2. So it will be 1 when t is bigger or equal to a. Okay, when t is bigger or equal to a. But guys, because a must be positive, so this one is undefined. Okay, it's undefined, right? Because a is negative. Okay, we can draw a graph of ut if and only if a is positive number. A is a positive number. Okay, so for ut plus 2, we can't really draw a graph for it. Okay, let's look at it a little closer. You have ut minus a, right? ut minus a is 1 when t is greater to or equal to a, right? And if you multiply this ut minus a by ft, it means that usually u of t minus a is actually 0 and 1, right? 0 here when t is less than a, and 1 here when t is bigger than a. Okay, so if you multiply it by ft, it will be 0, right? 0 times ft is 0 when t is less than a, and it would be ft when t is equal to or greater than a. Okay, makes sense? Okay, because u is 1, so if you multiply it by t or multiply it by ft, you would get ft when u is 1. And similarly, guys, here is a little more complicated. ut minus a minus ut minus b. Okay, guys, let's say if a is here, b is here. Okay, for ut minus a, here it will be 0, right? It will be 0, right? Because t is less than a, it will be 0. And here it will be 1 and 1, right? Because whenever t is bigger than a, right? For example, this point, t is bigger than a, right? Bigger than a, which means that ut minus a is 1. And guys, ut minus b here is 0 and 0 and 1, right? And 1, right? Makes sense? Because ut minus b would be 1 when t is bigger than b. Sorry. So we would have that ut minus a minus ut minus b would be, its point would be 0, right? Because 0 minus 0 is 0. Here it would be 1. And here it would be 0 because it will be 1 minus 1. Cool? So whenever, guys, whenever you have ut minus a minus ut minus b, that is to say that, okay, this guy is 0 when t is less than a, and it's 1 when t is bigger than a but less than b, and it's 0 again when t is bigger than b. Okay, so if you multiply that function colored in pink with ft, you would get the same. You get 0 here, you get 0 here, you get 0 here, you get 0 here, and you get 1 here, you get ft. Because you multiply ut minus a minus ut minus b by ft. Okay, so that's why you get ft there. Sense? Okay, so let's look at this example. Okay, draw a graph of psi t. Okay guys, what is the graph of psi t? Do you know that psi 0 is 0? Okay, and psi half pi is 1, and then psi pi is 0 again. Psi 3 pi over 2 is minus 1, and then psi 2 pi is back to 0, and then again it goes like that. Okay, that's psi t. Okay, so if you want to draw a graph of psi t u t minus half pi, it means that it would be 0. It would be 0 when t is less than half pi, and it would be 1 when t is bigger than half pi. So if you have half pi here, sorry, it's not 1. The ut minus half pi is 0 and 1, but you multiply it by psi t. So here it needs to be psi t, right? Right? So to draw the graph of psi t u t minus half pi, gonna look like that. Okay, gonna be the same as psi t, but it starts here. Down here would be 0. Make sense? Okay. Okay. Let me use the pink color. So it would look like that. And here it will be 0. That is the graph of psi t minus half pi. Okay, it will be psi t when t is bigger than half pi, and it will be 0 otherwise. Okay, and guys, I forgot this square basket. So here, this guy, psi t u t minus pi minus u t minus 2 pi, it would be 0 when t is less than pi. Okay, and it would be psi t when t is bigger than pi but less than 2 pi, and it again becomes 0 when t is bigger than 2 pi. So in that case, the graph would look like that. Okay, just from pi to 2 pi, you get psi t, and above 2 pi and below 2 pi, you get 0. Okay, and that is the unit function. Okay, unit function is a good tool. It's a good tool for you to to define its step functions. Okay, we'll talk about that later. But as you can see here, you can limit the domain of the function using the unit function. Okay, nice. So here, write down the following function in terms of the step functions, okay, or the unit functions. Okay, write down the following function in terms of unit function. Sorry, let's change this to unit function. Okay, not step function. I haven't talked about the step function yet. Okay, but it's unit function. So here, like that, your ft would be 4e to the 2t, and then times u of, what is it, t minus 0 minus u of t minus pi. Okay, does it make sense? Because here this guy, it would give you 0 when t is, it's t minus 0, right? It's t minus 0. So it would give you 1 when t is bigger or equal to 0. And it would give you 0 when t is less than or equal pi. Okay? Okay? Sorry. Less than pi. Okay? Does it make sense? My bad. It will be 0 when t is bigger or equal pi. Sorry. And then you get plus 3 cos t. And then you get u of, what is it? T minus pi, right? Right. Because if you get u of t minus pi, it means that it would be 0 when t is less than pi, right? And it would be 1 when t is bigger or equal to pi. Okay? In that case, you will get 3 cos t. And that's it. Okay? Next example. Write down the following function in terms of unit function. Okay, so ft would be t squared plus 2, and then times u, what is it? T minus 0 minus u of t minus 2. Okay, and then 0 times u of t minus 2 minus u of t minus 3. Actually, this one you don't need to write it down because it's still 0, but I want to write it down because I want you to understand how to define the function. Okay, but actually it's 0 because it's multiply 0. It's always 0. And the last one would be plus psi pi t, and then you get u of t minus 3. And that's it. That is how you define a function in terms of unit functions. Good? Good. And the next example, it would be 3. ft would be 3 u minus 0. Sorry, ut minus 0 minus u of t minus 2, and then plus t cubed plus e to the minus 2t u t minus 2 minus u t minus 3, and then plus 0 u t minus 3. But again, guys, this one is 0. You don't need to write it down. Okay? And that's it, guys. As simple as it is. Okay? Okay, and here is the technique to find the Laplace transform for step functions. Okay, so basically Laplace transform of f t minus a ut minus a is e to the minus as Laplace transform of ft. Guys, here it's quite important that you need to have ft minus a, not ft. Okay, it's ft minus a, not ft. Okay, so let's look at this example. Here, you can see that here you have u of t minus 1, which means that you can tell that a is actually 1. So here, this function, this function, it needs to be a function of t minus 1, right? Right? Makes sense? But as you can see, t minus 1 cubed e to the 3 minus 3t is actually t minus 1 cubed e to the 3 1 minus t, or it's actually t minus 1 cubed e to the minus 3 t minus 1. So you can write it down in terms of t minus 1. Okay, so we have that f t minus 1 is t minus 1 cubed e to the minus 3 t minus 1. Okay, okay, okay. Ft minus 1 is t minus 1 cubed e to the minus 3 t minus 1. In that case, we have that ft. Basically, you substitute t minus 1 with t. Okay, yeah, you can look at it as, you know, like let's use the green color. F of the box is box cubed e to the minus 3 box. Okay, is f of t minus 1 is t minus 1 cubed e to the minus t minus 1. So you can substitute the t minus 1 with anything, right? With a box. And of course, with the box, you can substitute t minus 1 with t. So you get t cubed e to the minus 3t. So once you get ft, you have that Laplace transform of f t minus 1 u t minus 1, which is actually this guy, right? Oops, sorry, not that guy. The other guy. This guy, right? Right? Because right now, our f t minus 1 is actually this guy, right? Which is actually the guy here. Make sense? Sense? So this is actually the question, okay, the problem. So it can be written as e to the minus a is 1, right? So it's minus 1s Laplace transform of ft, which is t cubed e to the minus 3t. And that would be okay, I'll continue writing it here, okay? And that would be e to the minus s. Guys, how to do Laplace transform of that? The Laplace transform of e to the minus 3t, t cubed, and then we apply the the first technique, right? We look at this as a, you know, f star t. Okay, I don't use ft because we already have ft here, so I need to use some other f. Okay, so I use f star. Okay, so just to, you know, to make it correct mathematically. So here it's the same as the e to the minus s Laplace transform of t cubed, and then you change s to s plus 3. S minus 3 is s plus 3. So you would get e to the minus s. Laplace transform of t cubed is, what is it? is 3 fact divided by s to the 4, right? And then you change s to s plus 3. In that case, you have that it is actually e to the minus s 3 fact s plus 3 to the 4. And that's it. Very simple. Okay, so guys, if you want to apply this technique, first you need to write down this function in terms of ft minus 1, because as you can see, it's ft minus a ut minus a, and you have t minus 1 here, which means that this function needs to be the function of t minus 1. Okay, and I can tell you that here it can be written in terms of f of t minus 1. See, it's t minus 1, t minus 1. So you get ft minus 1 like that. So if you get ft minus 1 like that, you can find ft by substitute t minus 1 with t. Okay, by substitute t minus 1 with t. Okay, and once you get ft, you can apply this formula, right? You have ft now. So you have ft now. The Laplace transform of this, which is this, would be e to the minus as Laplace transform of ft. And to find this Laplace transform, we need to use the first technique. Okay guys, you can also use the second technique, but as I told you, the first technique is easier. Okay, because here, if you apply the second technique, you need to differentiate 3 times, and it's not fun. Okay, so you can find this like that using the first technique, and then that is the answer. Very simple. Okay, the second question here, we want to apply this technique, right? The third technique, which is the technique to find the Laplace transform for the unit function. But as you can see, you need ft minus a ut minus a, and here you have ut minus 2. It means that this guy need to be f of t minus 2. Okay, but it's not quite clear how can we write it in terms of ft minus 2. Okay, it's not very clear. So how to write it down in terms of ft minus 2? Okay, so first we investigate this function. Okay, and then I write it down in terms of t squared, and then I minus 4t, and then I plus 4t and plus 3t. It's okay, isn't it? Because I minus 4t and then I plus 4t. There's no problem about that. Okay, so we have t squared minus 4t, and then I plus 4 minus 4, and that is also okay, right? So we have plus 4t plus 3t. And guys, if you look here, it's actually a squared minus 2a a squared minus 2ab plus b squared, right? Because if you look at here as the a, okay, let me write it down a little bit. T squared minus 2 t2 plus 2 squared. Okay, here is the expression in pink, and the rest that would be plus how to write it in terms of, okay, anyway, it's 7t minus 4. Okay, 7t minus 4. So here this guy becomes t minus 2 squared. Okay, at least I get some t minus 2. Okay, and then plus 7t, and then there's no problem, right? I can minus 14, and then plus 14, and then minus 4, right? And minus 14 plus 14 is the same as plus 0, right? And in that case, I have that is t minus 2 squared plus 7, t minus 2 plus 10. Okay, so right now, that guy, right, the guy in green is now a function of t minus 2. It's now a function of t minus 2, right? So I can write down ft minus 2 as t minus 2 squared plus 7 t minus 2 plus 10, which means that ft would be t squared plus 7t plus 10. Okay, so ft is t squared plus 7t plus 10. Basically just substitute t minus 2 with t. See, whenever you see t minus 2, you change it to t. Okay, so from the previous technique, we have that Laplace transform of t squared plus 3t u of t minus 2 can be written as e to the as, right? E to the minus as, right? E to the minus as. Right now, a is 2. Okay, so it will be e to the 2s Laplace transform of ft. So let me continue here. I would have that it is e to the 2s Laplace transform of t squared, then plus 7 Laplace transform of t plus 10, and that will be e to the 2s. That would be 2 fact divided by s cubed plus 7 1 fact divided by s squared plus 10. Sorry, here it's not just 10, it would be 10 L1, right? It will be 10 Laplace transform of 1, right? So that would be Laplace transform of 1 is 1 over s, right? So we have 10 over s. Guys, here is nothing, it's ft, right? I just put this ft in there. Okay, I just substitute ft with this expression, and then I apply the Laplace transform to each term. Okay, and that is the answer. Okay, as simple as that. That's it. Good. Okay. Oops. Sorry. It's e to the minus as, right? E to the minus as, not e to the as. Sorry, you have minus here. You have minus as, not as. Okay. Okay. If you have any questions, just let me know. Okay. When you know, you can message me, or we can talk when we have the live class or the on-site class. Okay. So next example, we want to find the Laplace transform of e to the t cos 2t u 1 minus 2t 2 pi ut minus 2 pi. Sorry, I don't know why I said it like that. Okay, so guys, to do the Laplace transform of this function, first, don't use the third technique. Okay, don't apply the third technique. We apply the first technique first. Okay, here, because here we have e to the t, right? E to the t, which means that is e to the 1t. So in that case, the Laplace transform here, this guy, can be written as L of cos 2t u t minus 2 pi, and then you shift it s to s minus 1. Does it make sense? Does it make sense? Okay. So before we actually apply the third technique, we actually apply the first technique first, and it's gonna make it a lot easier, right? So right now, to find this Laplace transform, we're gonna use the third technique. So we know that this function must be f of t minus 2 pi. Okay, it will be f of t minus 2 pi. Okay, so let's observe cos 2t. Cos 2t is the same as if I minus 4 pi and then I plus 4 pi. It's okay, isn't it? So it will be cos 2t minus 2 pi pi and plus 4 pi. Guys, from trigonometry, you know that cos of a plus 2n pi is the same as cos a, right? Because whenever you plus 2 pi, 4 pi, 6 pi, 8 pi, you get back to the same place, right? Because the whole circle is 2 pi. Okay, so this is the same as cos 2t minus 2 pi. So we have that ft minus 2 pi is cos 2t minus 2 pi. So if we do substitute t minus 2 pi with t, we have that ft is actually cos 2t. So we have that Laplace transform of e to the t cos 2t u of t minus 2 pi would be a Laplace e to the a minus a s, right? It would be e to the minus 2 pi s Laplace transform of cos 2t. And then guys, don't forget that we used here, so we need to change s to s minus 1. So that would be e to the minus 2 pi s Laplace transform of cos 2t, that would be s divided by s squared plus 4. And then you change s to s minus 1. So the answer would be e to the minus 2 pi s minus 1 divided by s minus 1 squared plus 4. That's it. That is the answer. Okay, cool. So first, when we see this, we apply the first technique. Okay, so once we apply the first technique, we can get rid of e to the t. We just need to find the Laplace transform of this guy, and then we shift s to s minus 1. Okay, so to find Laplace transform of this guy, we're gonna be using the third technique. Okay, so to apply the third technique, here it needs to be the function of t minus 2 pi. So I have that cos 2t is cos 2t minus 4 pi plus 4 pi. Here it's the same as plus 0, right? So it's no problem. Okay, and here I pull 2 out. Okay, here is 4 pi. But guys, cos of a plus 2 pi or 4 pi is the same as cos a. So here I can get rid of this. I get cos this. Okay, and then we have that f2t minus 2 pi. It's cos 2t minus 2 pi. So ft is cos 2t. And then we apply the third technique. Okay, and we get the answer. Okay, the next question here, it looks hard, but it's actually pretty easy. So first you need to write down this function ft in terms of unit functions. So you would get psi t and u of, what is it, t minus 0 minus u of t minus pi, and then plus 2 u of t minus pi. Okay, that would be what you would have. Good, good. And guys, that would be psi t u of t minus psi t u of t minus pi plus 2 u of t minus pi. Okay, ut is actually 1 when t is bigger than 0, right? Right. But guys, our function is defined when t is bigger or equal to 0 anyway. So whenever you see ut, it's the same as you don't write ut because it's always 1. Ut is always 1. Right? Right? So here you can get rid of ut. Okay? Again, guys, ut minus a. Let's use some other color. Ut minus a is 0 when t is less than a, and 1 when t is bigger or equal a. Okay, but when a is 0, okay, when a is 0, it means that ut is less than 1, right? Because a is 0, it's gonna be 1 when t is bigger or equal to 0, but t is always bigger or equal to 0, right? Just don't forget, guys, the whole section, the whole chapter is based on the assumption that t is always bigger or equal to 0. Okay? Okay? So guys, take home message. Whenever you see ut, just get rid of it. Okay? Just get rid of it. Good? Okay. So here is going to be psi t plus 2 minus psi t ut minus pi. So the Laplace transform of Ft would be Laplace transform of psi t plus Laplace transform of 2 minus psi t ut minus pi. Okay, here Laplace transform of psi t, there's no problem about that, right? It's just, what is it, 1 divided by s squared plus 1, right? So what is the Laplace transform of 2 minus psi t ut minus pi? Okay, so we want to find the Laplace transform of 2 minus psi t ut minus pi. Okay, to find the Laplace transform of that, you need to look at ut minus pi. Okay, so u minus 2 minus psi t must be the function of t minus pi. So 2 minus psi t is 2 minus psi t minus pi plus pi. Okay, and that will be 2 minus psi t minus pi and plus pi. Okay, but guys, if you go back to the trig properties, it's really far away, but yeah, you have it somewhere. It's here. So psi of a plus pi is actually minus psi a. Okay, so psi of a plus pi is actually minus psi a. So here is
sine A plus pi. It would be 2 minus minus, right? Minus minus is plus, right? Sine A. Okay. So it becomes minus sine A. Okay, the thing in yellow is A. Okay. So we have that f of t minus pi is 2 plus sine t minus pi. So ft would be 2 plus sine t. Okay, we substitute t minus pi with t. So we have that. We have that. The Laplace transform of 2 minus sine t ut minus pi is e to the minus as, right? E to the minus as. A right now is pi. So e to the minus pi s Laplace transform of 2 plus.
And that would be e to the minus pi s uh, 2 Laplace transform of 1 plus Laplace transform of psi t. And that would be e to the minus pi s 2 divided by s plus s divided by s square plus 1. Okay, let me get rid of my video. Okay, so guys, this Laplace transform would then becomes, okay, let me get the star here, so I don't want to write it again. Okay, it becomes 1 divided by s 1 divided by s squared plus 1, which is from here, this guy. Okay, plus e to the minus pi s 2 over s plus s divided by s squared plus 1, and that's it. Okay, oops, sorry guys, the Laplace transform psi, this is the Laplace transform of cos, sorry, my bad, it will be 1, not s, be 1. Okay, 1 over s squared, that's 1, and that's it. Okay, so guys, you can try doing this one as an exercise. Okay, so you first need to write down this function in terms of, you know, the unit functions. Okay, okay guys, first let me change the boundary here to 1, and here is 1 to 2, and here is above 2. Okay, and you can try solve this Laplace transform. Let me start it for you. Ft can be written as t of t e to the 2t ut minus u of, what is it, t minus 1, and then plus 0 plus 4e to the minus 2t plus t cubed u of t minus 2. Okay, that is what you should have. Okay, but guys, as you know, this is actually 1, right? Ut is always 1. Okay, okay, because as you know, as I explained to you before, ut here, it always is always 1. That's why you can get rid of it. Okay, so ut is 1. And then you apply the Laplace transform throughout the equation. After that, you get the solution. Okay, so guys, this is the second lecture, right? The second lecture for chapter 3, and this is the technique of Laplace transform part 1. Okay, you're gonna have another part, so here is part 1. in the next part, okay, the techniques of Laplace transforms have two parts, okay? This is the first part. So we already learned three techniques, okay? E to the at, right? ft, t to the n ft, and the unit functions. In the next video, we're going to be learning the step function, and the convolution. Okay, the convolution. Okay, we'll talk about that later, like what they are and how to find the Laplace, their Laplace transforms. Okay, and in the next video, we're gonna finish the second section, which is the techniques to Laplace transform. Just in case you forget here. Okay, the first is a basic. That is the first lecture, right? And then we look at the basic Laplace. Sorry, the first lecture is a basic Laplace transform, including the table, right? The basic formulas. So this video is about the second section, which is the Laplace transform techniques, and this one is split into part 1 and part 2. So in the next video, we're going to be looking at part 2, okay? And after that, we're going to begin the inverse Laplace transform later. Okay, cool. So see you in the next video. Bye bye.